Welcome back to another tutorial for Game Dev Club. Last time we talked about conditional statements and user input. So this time we're going to be talking about loops. Now, a lot of times in programming, you want to do the same thing over and over and over and over again. And to do this, it's really annoying to just have multiple lines of code that are exactly the same. So there is what's called a loop. A loop basically just does code over and over again, so we're just going to make a new Java project. We're going to call it loops. Alright. So our first class, or we're first going to talk about the while loop. There are different types of loops. There are three main types of loops that I will show you today. This is going to be while loop. While example 1. Alright, oh, I forgot to make this class runnable. Okay. Oops. There we go. Alright. So, to do a while loop, we need what's first called an initializer. So, initializer. That's just a normal variable. Int x equals 0. So, you're setting x to 0. And then we want our limiter. And while loop start. Alright, so our limiter is a boolean, so it's x is less than 6. So our limiter, what it's doing is it's when this boolean is true, going to execute this code, and it will keep doing it until this is false, and it will not go on until it finishes the loop, or if it just skips the loop. So let's just do a system out. Oops, I did the wrong shortcut. There you go. If you do if you just type sysout and then you control space, it automatically has your system out right there. Alright, sys out. Alright, and then a loop has what is called an incrementer. An incrementer, oops, need 2 there. An incrementer, what it does is it spells correctly. Yeah, I guess incrementer works. The incrementer, what it does is it changes it kind of modifies the boolean. It's called an incrementer because generally the boolean is a less than something and you do plus plus, but you can put a normal boolean. If you put while true, you will see that it causes an endless loop, and it'll just go on forever and ever and ever and ever until integer has reached its maximum. So we don't want that. We want to limit it. So we're going to do x is less than 6. Because if we have anything under here, it'll be redundant. So if we have, or unreachable. So if we have while true, and then we have another sys out, and we say loop is done. This loop is done code will never happen. Something's wrong with my system out. There you go. It's unreachable. It doesn't even want to compile it. So x minus 6, or x is less than 6. And there you go. It starts at 0 because x was 0 when it started. And it goes 1, 2, 3, 4, 5. And then it did. So we do system that out. Actually, x would be 6. Because what it did, because what it did is it incremented x. So then when it got here and x was 5, then x was 6 and it came back here and 6 is not less than 6, so it went outside of the loop. So I'm actually going to get rid of this loop is done as well. Alright, so yeah, so as you can see, it has a very similar syntax as an if statement, but it's not exactly. So alright, so like an if statement, if the given boolean is false, the while loop will just kind of skip. Example 2. The while loop will just kind of not happen. So let's do the same thing we had last time. So we're gonna have int x equal to 0 while, but instead of x is less than 6, we're gonna do x is greater than 6. I'm gonna do this out. X plus, our output will be blank. Nothing happened because x is 0, so it goes into this while loop and sees that x is not greater than 6, so it just basically ignores the rest of the loop. So alright, so let's combine our input with a while loop. So let's just say we have a random game that has the user entering a number, but will keep asking the user for a number until the user enters 5. Alright, we're going to do scanner input. Alright, here's another thing. If you don't do import right away and you try to use this, it will give you an error. You can either go here and click here and it'll automatically do it, or you can just press Ctrl Shift O. It's another way to do it. Or if you want to do another one, there's a Ctrl Shift M. But you have to be, there we go. Your cursor has to be on the word of the name of the class. Anyway, so input equals new scanner system. You do sysin. No, fine. Find Eclipse, be that way. System.in, you guys all remember this. Ensure x. So alright, so we're gonna do a sysout. Please enter a number. Then we're gonna do x is equal to input dot next integer. Alright. Then we're going to do while x is not equal to 5. We're going to have it do this again. So then when it's done with that loop, so then x will no longer be 5, or x is no longer not 5, so x is 5. You got 5. That close. Alright, let's take a look at this. So I'm going to do 2 input outputs. So I'm going to put in my first number. It's going to be 1. I'm going to put in 6. I'm going to put in 2. Then I'm going to put in 5. Then it finally got, you got 5. And then it terminated. What happens when we just enter 5? Just as you got 5. As you can remember, x is not equal to 5, but x is 5, so it will just skip this loop. But as you can see, we have these 2 lines of code, and they're exactly the same. So there's a way to do something similar to this, well, to do exactly this with less code. It's called a do while. A do while has a different syntax, but it has pretty much the same structure. So let's do the do while example. There, just have that in my clipboard for future reference. Scanner input equals new scanner system.in integer x. Alright, so now we're going to start our do while. So a do while pretty much does the loop no matter what, and then it checks if the limiter is true. So we end up with a semicolon. Oops. Alright, so we have our initializer. Our initializer and our incrementer are actually the same thing because it's just out. Please enter a number. X is equal to input.nextIt. Alright, so basically it's gonna do this, and then this is our incrementer. As you can see, it's a user input, so it's not exactly plus plus, but it's still an incrementer, and we have our limiter. It does it regardless, no matter what, and then it checks the limiter, and if it's true, it loops this. So let's this out. You got 5. Same thing as before. So let's do input. So let's see the input output. So I'm going to try the same thing as last time. So 1, 6, 2, and then 5. You got 5. Alright. So then just enter 5. As you can see, it still did it. And I did not close the input. I'm sorry. Alright, so as you can see, this thing took two less lines of code than the other one. It's just less work. It's these 2 lines that I didn't do. It's just less work, and it's less of a hassle, and it's less code for the computer to process. And whenever there's a method that requires less code, it's good, because sometimes more code will cause your computer to slow down, and especially in game development, you'll have a laggy game, and no one will buy your laggy game. So as I said, there's 3 main types of loops. So we just looked at the while loop and the dual while loop. There's one more. It's called a for loop. So for example 1, I'm going to take a look at the for loop. So a for loop has the same initializer, limiter, and incrementer, but they are all in one thing. So let's do it. So int I, we initialize this variable inside the loop, inside the parentheses, and then we put a semicolon. So this is our initializer. Then we're going to put our limiter, and now we're going to put I++, our incrementer. Now we're going to just do sys out I. Use I when you're in a for loop, or generally in loops you use I. 1, 2, 3, 4. Generally in loops you use I because it's just, you'll see why when I talk about arrays in the next lesson. So if you want to do an endless loop, you just put 2 semicolons there, and it'll just do you just put 2 semicolons there, it'll just forever print out hello. Oh lord. Alright. Look, it didn't finish. Where's that last one? That's really interesting. Didn't finish printing it out. Because it prints out the characters one by one. That's how a string works. It's a list of characters. Hell. Oh, that's fun. Anyway, so we're gonna go back to our loop. Again, 1, 2, 3, 4. So the while loop has now this boolean. This is a boolean. I guess you can do true right here. and everything underneath the code will be redundant. This one also failed to print out all the way. So yeah, so now we're gonna make a simple program that checks if a number is prime. Now to do this, we'll be learning about a keyword that is break. So the break keyword pretty much forces the computer to exit the loop if the given boolean is still true, even if the given boolean is still true. So yeah, we have a condition that will only sometimes occur, and its loop must end. So we're gonna go ahead and make a new class. It's gonna be called getPrime. Alright, so we're just gonna name it. We're gonna start. My microphone just fell. I am so sorry. So scanner input equals new scanner system.in. Alright, and we're gonna do this out. Enter a number to check if the number is prime. So now we're gonna make a boolean is prime. Now we need to initialize it, just because. Int x, int I. So x is equal to input dot next int. So x is not our initializer. Actually, I is equal to 0, or I is not equal to 0. It's equal to 2, because I'll show you in a second. It's just math, basically. So while I is less than x minus 1, if x remainder I equal to 0 is prime is equal to false, else is prime is equal true. I plus plus. Alright, break. So basically, let me just finish the program real quick. If is prime, sys out x is a prime number, else sys out x is a composite number. Alright, and then input dot close. So basically what it's doing is, alright, so when a number is prime, that means a number that is not 1 or itself can divide into it evenly, meaning there is no remainder. So we don't want to start I at 0, because 0 you can't divide it by 0, because that's divide by 0 error. And if you divide it by 1, the remainder will be 0. So we want to start at 2. So if x remainder I is equal to 0, so if I divides into x evenly, so it gives you 0 as a remainder, is prime is equal to false, so it's not prime, and it breaks out of the loop. It ignores the rest of the numbers, because you can also say that it's the smallest factor other than 1, but for now we're just saying that it's a composite number. Else is prime is equal to true, and then it continues the loop. So break just forces it out. So let's test this out a little bit. So let's put in, for example, 708. Alright, num block is off 708. 708 is a composite number, but if we put in, for example, 17 is a prime number. If you put in 563 is a prime number. If you put in 24 is a composite number. If you put in I don't know, 60. Let's not do another even number. Let's do 81. 81 is a composite number. So that's about it. There's more to loops than I showed in this video, but you need to learn about arrays first in order to use them. So arrays are cool, and I'll teach them next time. So until then, see you later. Bye.